All right, this problem says a translation is applied to triangle PQR to create triangle P prime, Q prime, R prime. So on the graph here, we have triangle PQR. Remember, that's our pre-image. And then P prime, Q prime, R prime is our image. The question wants us to create equations for A in terms of X and for B in terms of Y that could be used to describe the translation. So here, essentially, what they're asking you to do is figure out how many units do they translate which directions to get PQR to P prime, Q prime, R prime. But you have to answer the question in a very specific notation or it's not going to be correct. So when it says create equations for A in terms of X, we know that A is going to equal X plus or minus something because we need that X in there. We're saying you take your original X coordinate and you move this many units to the right or this many units to the left. For our B, it says write equation for B in terms of Y. So that means our B equation is going to be talking about our vertical movement, our movement up and down. So we know B is going to equal Y plus or minus something, depending on whether we're moving up or down to get from our pre-image to our image. Now we want to look at the picture. It looks like to get from P to P prime, we're moving to the left, so we know it's going to be X minus a number because we're moving left. And then we're moving left 1, 2, 3, 4 units. So A equals X minus 4 is the equation that describes the translation, the first one. It's saying to take your X coordinate and move 4 to the left to get your new X coordinate. Then after we move left 4, we have to move up 1, 2, 3 to get from P to P prime. So our B equation is going to be B equals Y plus, because we're moving up, 3. And that's saying the equation for B is saying we take our Y coordinate, we add 3 to it, so we move up 3 to get from P to P prime, or R to R prime, or Q to Q prime. A lot of people here, they just want to write this. They want to say A equals -4 because they see that we move left 4, and they want to put B equals 3 because we went up 3. Now, if that's your answer, you understand what's going on in the picture, but you did not put your answer in the correct format, thus making your answer incorrect. So you really want to make sure you pay attention to how the problem's asking you to input your answer and that you're entering your answer in the correct format. Here, triangle MNO is transformed to produce triangle PQR. Select all of the transformations that would guarantee triangles MNO and PQR are congruent. So here it's a select all, so that means there could potentially be more than one correct answer. So you don't just want to stop once you find one answer that works. A lot of people, when they see this question, the first thing they say is, how am I supposed to answer this? There's no picture. There's no graph. I don't know what triangle MNO and triangle PQR look like. And that's okay. You actually don't need those things to answer this question. What you do need is a good understanding of what the word congruent means, and you need to know which transformations are rigid motions, or which transformations result in congruent figures. So remember, if it's two figures are congruent, that means they're the same size and they're the same shape. A rigid motion is a transformation that results in congruent figures. So we learned about 4 transformations. 3 of them are rigid motions, and those 3 would be reflections, rotations, and translations. None of those 3 transformations change the size of a figure. The only transformation that is not a rigid motion, which means it does not result in congruent figures, is a dilation. Because when you are dilating a figure, you are changing its size. So here, if we want to select all of the transformations that would guarantee the 2 figures are congruent, we know we cannot pick anything that includes a dilation, because a dilation is changing the size. So the first one that says a dilation, then a translation, that's out. A dilation is not a rigid motion. You are changing the size. The next one, it says a reflection. That's good. Reflections give us congruent figures. Then a dilation. That is no longer good. Once you dilate something, you are changing the size. Your pre-image and your image aren't going to be congruent. So that's out. Option 3 is good, a reflection then a rotation. That would result in congruent figures. The next one, a rotation then a translation. That would also result in congruent figures. We are not changing the size. And our last choice would also work. A translation, which means we're moving or sliding the figure, then a reflection or a flip. We're not changing the size, so those last 3 choices would give us congruent figures. All right, here this one says triangle ABC lies on the coordinate plane with vertices located at A, 8, 6, B, 2, -5, and C, -5, 1. The triangle is transformed using the rule XY is transformed into x plus 3, 2y to create triangle A', B', C'. Determine the coordinates of triangle A', B', C'. So here the problem is telling us the rule. It's telling us exactly what is going to happen. We just need to take that coordinate rule and apply it to the coordinates that it gives us. So xy is transformed into x plus 3, 2y. What that is saying is to find the new coordinate, to find the new x coordinate of all our points, we're going to take our original x value and add 3 because it's x plus 3. Then to find the y coordinates of all our prime points, we're going to take our original y value and multiply it by 2 because 2y, that's 2 times y, it means we're multiplying. So if we were going to do A prime together, first we would take our original x coordinate for point A, which is 8, and we'd add 3 to it because that's what the rule is saying. It's saying take your x value and add 3. Then we take our y value, which is 6 from the original problem, and we'd multiply it by 2 because the problem is saying to find your new y coordinate, do 2 times your original y. When we do that, 8 plus 3 is 11, and 2 times 6 is 12. So the coordinates of A prime are 11, 12. And now you will do that with B prime and C prime. So you'll use the same coordinate rule to find the coordinates of B prime and C prime.